All right. So in this first example, we have that the secant of u equals negative 3 halves. The tangent of u is greater than 0, and we want to find the values of all 6 trig functions. So do you know what your 6 trig functions are, right? Sine, cosine, tangent, secant, cosecant, cotangent. They already gave us secant. So if we know that the secant is negative 3 halves, the reciprocal function for secant is the cosine. So then we could say that cosine is negative 2/3. So from that given piece of information, we can come up with 2 of the 6. Something you need to think about is here they tell you secant is negative and tangent is positive. So if we're thinking about unit circle, you have to determine what quadrant would secant, which would mean cosine 2, also be negative. So remember, cosine is negative in the second and the third quadrant. And then we need to figure out what quadrants is tangent going to be positive. And tangent's positive in the first and the third. So since we have both of these in the third quadrant, we're going to draw a triangle in the third quadrant. So if we drew a triangle with a right angle, and this is our angle measure, if we know that the secant is negative 3 halves or the cosine is negative 2/3, right? Remember, cosine is the adjacent over the hypotenuse. So then we know our adjacent side is negative 2 and our hypotenuse is 3. Hypotenuse is always positive. And then we can use Pythagorean theorem. So we could say negative 2 squared plus b squared equals 3 squared. B squared equals 9 minus 4, so it's 5. So b is the square root of 5. So this side over here is the square root of 5, but because it's below the x-axis, it has to be a negative root 5. And then once you have the triangle with your 3 sides, then you can write your other ratios. So we know then that the sine is opposite, which is negative root 5, over hypotenuse, which means then that the cosecant is the hypotenuse over the opposite. They're just reciprocals. We could say that the tangent is opposite over adjacent, so is a square root of 5, negative root 5 over negative 2. And since they're both negative, it would be positive. And then the cotangent would be 2 over root 5. All right, so then on this next example, we need to simplify sine squared times secant minus secant. So where you see that sine of x squared, that means the same thing as the sine squared times the secant minus the secant. And when you're trying to simplify these expressions that have the same trig function in more than one term, sometimes it might make sense to factor out that GCF. So since the first term has secant and the second term has secant, we're going to factor out a secant, and then we'd be left with sine squared minus 1. And then think about your Pythagorean identities. If we look at our Pythagorean identities, we know that instead of saying sine squared minus 1, we could say that's the same thing as, be careful though, because you might say it's the same thing as cosine squared, but remember cosine squared is 1 minus sine squared. And we want sine squared minus 1. So we want everything, these two, the 1 and the negative sign, we want those to be opposite. So if you want both of those to be opposite, then we need to multiply everything by negative 1. So if you multiplied everything by -1, you would get negative cosine squared equals -1 plus sine squared. And -1 plus sine squared is the same thing as sine squared minus 1. So we could replace that with then a negative cosine squared. And then, instead of saying secant, we know that the reciprocal identity for secant is 1 over cosine. And if we're multiplying that by negative cosine squared, if it helps, you can put that over 1, so that way you have those two fractions. Now, when you have a cosine in the numerator, cosine squared in the numerator, cosine in the denominator, those will simplify, and you'll just be left with negative cosine of x. All right, so for example 3, we're going to factor. So everyone's favorite. Sine squared minus cosine squared, so maybe rewrite it. Like, I like that squared on the inside. If you like it on the outside, that's fine. So sine squared minus cosine squared. Our goal is not to solve for anything. We're just trying to write it in factored form. So because sine is a perfect square and cosine is a perfect square, we could factor this as a difference of squares. Right, so just that little reminder, if you had x squared minus y squared, that would factor into x minus y and x plus y. So if we have sine squared minus cosine squared, that would factor into sine minus cosine times sine plus cosine. And we're stopping there. We're just working on factoring. The second one for B is a little bit different because this is really just like your general quadratic polynomial, but we have a trig function in there. So one trick is that if your functions are all the same, if it kind of throws you off to factor with that function in there, then just substitute a letter in there to factor, and then we can substitute back in. But you can only do that if the function's the same all the way through. So if we wanted to substitute in for cotangent, we could say that u equals the cotangent of x. And that would give us then 6u squared minus 13u plus 5 as a polynomial that we want to factor. So some of you are good just kind of guessing and checking and getting your factors. For some of you, especially when that leading coefficient isn't a 1, that can be trickier to figure out those numbers. So let's work on splitting the middle here. So our first thing we have to do is think of what two numbers multiply to give us positive 30 and add to give us negative 13. So again, we have to multiply to get positive 30, and we have to add to get negative 13. So that's what we're splitting, right? The positive 30 came from 6 times 5. So maybe negative 3 and negative 10. Does negative 3 and negative 10 multiply to give you positive 30? Does it add to give you negative 13? Yeah. So we'll go 6u squared minus 3u minus 10u plus 5. So that's splitting the middle as we split that negative 13 into a negative 3 and negative 10. So then we can group. If we group that 6u squared minus 3u, the GCF is 3u, and we're left with 2u minus 1. And if we group a negative 10 plus 5, our goal is to get a 2u minus 1. So let's factor out a negative 5, and we're left with 2u minus 1. So if we put that together, then we have 3u minus 5 times 2u minus 1. So it's factored, but we still have to go back to that last step because remember we put that u in there just to make it a little bit simpler. So now we have to substitute that cotangent back in at the end. So our factor would be 3 cotangent x minus 5 times 2 cotangent x minus 1. All right, so let's look at the next one. We're going to factor this again, and it looks quadratic, right? We have a cotangent squared minus 2 cosecant minus 7. But the difference in this one and the one we did before is that we have cotangent squared, and then our other trig function is cosecant. So we can't just substitute a variable in and call it good since they're different. So you need to go to your formula sheets and see, is there maybe a formula that you could use that you could substitute in, probably for cotangent squared, since your Pythagorean identities are all in terms of the squareds. So if we were to look at that 1 plus cotangent squared x equals cosecant squared x, see that formula on your sheet? So instead of cotangent squared, if we were to solve this, we would say that this is cotangent squared is cosecant squared minus 1. So if we were to replace that cotangent squared with the cosecant squared minus 1, and then we left everything else, now you've created this quadratic that has all of the same trig functions in it. And so then it's like that last one we just did. So then if we have cosecant squared minus 2 cosecant, and then combine the -1 and -7 and get -8, now you just have that polynomial where the functions are the same in every term if you have it. So then if you did that u substitution, if you let u equal cosecant and substitute it in, you would have u squared minus 2u minus 8. And now you have to factor that. This one has the leading coefficient of 1, so let's just think about what multiplies to give us -8 and adds to give us -2. -4 and +2. And then that last step, remember, is substituting back in for your u value. So cosecant x minus 4 and cosecant x plus 2. Now here's the thing. If you look at this, if you're someone who looks at that step right there and the cosecant doesn't throw you off, then you don't have to rewrite it with the u in there. If you can factor it with the function in there and that doesn't kind of like put too many things together, then skip the u substitution step. You don't have to do that step. That's just to try to simplify it to make it look a little bit easier and not as complicated to factor. All right, let's look at this one. We're not factoring, we're simplifying. So remember kind of that first one we did when we had to simplify and we had 2 terms. We factored whatever that GCF was out of the both terms. So when you look at this expression, we have a secant of t in both parts of the expression. So we're going to factor out our secant t, and then we're left with a cosecant t minus a sine t. Okay. And again, the way that I'm simplifying it, you may think about it a little bit differently, but what happens is that as long as you do it correctly, you'll end up in the same spot. So where I'm factoring out a secant, maybe someone else is changing the cosecant and secant into reciprocal functions to start. And it can work that way too. So there's more than one way you can approach these problems. So what I'm going to do here is leave that secant. Since I have a sine right there, I'm going to change cosecant into 1 over sine. So I'm starting to get those similar functions. Now think about your fraction rules. If you want to subtract 1 over sine minus sine, you need a common denominator. So if that first one has a denominator of sine, we're going to multiply that other one with a denominator of sine, which means then we also have to multiply the numerator by sine. So we have the secant of t times, if we were to combine this into a single fraction, our numerator is 1 minus sine times sine, which is 1 minus sine squared over sine. Okay, something we're not going to do, it'll go on the don't do it board, is, I'm going to highlight this just to show you in red. We're not going to say that this and this simplifies. Because if you do, you've left out the 1, and we can't leave anybody out. So if you have multiple terms, if you want to simplify, every single term has to be able to simplify. Otherwise, it's wrong. So we're not simplifying those. What we're going to do, which I'm sure is what you all would have done anyway, is look at our formulas and think to ourselves, 1 minus sine squared is actually cosine squared. And the reason you might want to do that is because instead of saying secant on the outside, you could change that to 1 over cosine times cosine squared over sine. So now you have a cosine in the denominator, a cosine squared in the numerator, and you're left then with cosine over sine. And we know that sine over cosine is tangent, which means that cosine over sine is cotangent. So that whole thing is just a fancy way of saying cotangent. All right, and then, the last one, we're just rewriting it. So we must be able to somehow simplify this. So again, when you see sine squared in your numerator, it tells you to rewrite it, and there's something with a cosine in your denominator, you're probably going to use that Pythagorean identity. So instead of saying sine squared, we're going to say 1 minus cosine squared over 1 plus cosine squared, or 1 plus cosine. Okay. We have 4 terms, 1 cosine squared, 1 and cosine. None of them all have the same thing in common, so we can't simplify anything just by crossing it off. So now you have to be a little bit creative and think about the fact that 1 is a perfect square and cosine squared is a perfect square. So you have a difference of squares. We're subtracting 2 perfect squares, so we could actually factor that numerator as a difference of squares. So we could factor that into 1 plus cosine times 1 minus cosine over 1 plus cosine. And then that last step, hopefully you see, is those common factors, that 1 plus cosine in the numerator, 1 plus cosine in the denominator, which is just 1 minus cosine is what you have left. And 1 minus cosine does not equal 1 minus, or does not equal sine, right? Because don't remember that cosine squared equals 1 minus sine squared. But cosine does not equal 1 minus sine. You can't say if you take the square root of both sides that it just simplifies to that. So make sure that you're not doing this.